So what we have here is Algebra 1, 1.6. We're going to talk about relations today. Relations, guys, are things that are related together. So represented, that kind of say that are connected. And so in math, a lot of times when we talk about relations, we talk about this thing, a graph. We talk about this thing as a graph because we put these things on there. X, Y. And these are called coordinates. Okay? This is the coordinate system here, the coordinate plane. Your X, Y, where your X's are your horizontal axis, Y is your vertical axis, right? And it's associated with this of X, Y. So if I wanted to, I could have us plot 2, 3. Where 2 is my X direction, Y is the 3 is in my Y direction. And so if I wanted to plot this, I would go over 1, 2, and then go up 1, 2, 3, which is about here, and whoops, that would be 2, 3. So that is plotted point. That's a relationship that every time I put in or I see a 2, I will get a 3. So just plotting points tells us this. So again, you have your x-axis, your x direction. You have your y-axis, which is the vertical axis. Now, there is actually one special point that we actually name, and it's the here. What are the coordinates of that red dot? 0, 0. We call that, it's 0, 0, but what do we call it? Do we remember? It starts with an O. Origin. It is the origin. The origin of the whole thing is in the middle. Oops, turned on me. Oops, I forgot the I just messed up in there. There we go. It's the origin. 0, 0 is the origin. Any other point is named 2, 3, -5, 6, all of that stuff. Probably should talk about how that this is the x position. It's also the x coordinate. This is the y coordinate. It becomes an xy coordinate. And so we can plot those. So, looking at this, we can see a relationship on a graph by seeing several points on a graph. We can also see a relationship several other ways. So what are those? Well, 4 different ways. We can have ordered pairs. Is one way. We can have a table. I sometimes call this a T-chart. We can have the graph. And we can have something called a mapping. These are 4 different ways to represent the same relationship. So, what are some things about ordered pairs? We just had them there. We can have 1, 2. We can have -2, 4. And we can have 0, -3. So let's just say that these 3 points, or these 3 coordinates, are a relation. Let's demonstrate these in the 3 other methods. So if you have an ordered pair, it's really easy to create a table. A table, all it is an XY table or a T-chart where you make a big, larger, elongated T with X and Y in it, and I just place all my X values in the X spot, all my Y values in the Y spot. And so we have 1, 2. So our first point is 1 for X, 2 for Y. The next one is -2, 4, and 0, 3. So everybody's seeing a connection between ordered pairs and a table. You should be able to transfer back and forth. Everything will be just fine. Then it doesn't matter which one of these two I'm given, I should be able to graph it. And you graph it using an XY coordinate. And you try to make your spacing, your tick marks here, as even as possible. Otherwise you end up having problems. The graphs don't look so great. If you know you're not going to draw things very well, I would use a ruler, those things. But then you just have to plot it, like 1, 2, -2, 4, somewhere about there, and 0, 3. So we have those 3 points. They don't have to make a line, they don't have to make anything fancy, they're just a bunch of points right now. That's a graph. Now a mapping is like a road map. It's like someone, like a treasure map almost in a way, where they say, you're starting here and you're going to end up over here. And so what they do is they build two little islands or something like this, 2 circles, where we can put our inputs and our outputs. Now sometimes they use different words, and I'm going to place them on the bottom. We have our domain, and we have our range. Remember, domain are the values we put in, range are the numbers we put or take out. And so what we do is we take all of the x values and we place them in there. The thing about it is we never repeat a number. So if 2 numbers had a 1, you would just only have to write 1 once, or a -2 or a 0. And then I come over here, on my outputs, put my range, or my y values. And the whole idea is to draw a straight line that connects every input to its output. So I go to 1. 1 goes to what? 2. -2 goes to 4, and 0 goes to 3. That is a mapping. Now, I'm going to change this up a little bit because things can happen. If I'm going to change colors. What happens if I put an extra point in? What if I put the point 1, negative, or I'll say 1, 4. Let's put 1, 4 into this mix. Then I have to go to my table. I have to put 1, 4 onto my table as well, right? I also then need to go graph it. 1, 4, there it is. But then I have to go to my mapping, because this is where I think the biggest difference comes in from what we just have. That means 1 on my inputs here doesn't change. My inputs will never change because 1 is already here, so therefore it's already there. Don't need to write it twice. But 1 not only goes to a 2, it also goes to a 4. And so I draw another straight line from 1 going straight across to 4. Now here's the thing. If I just gave you the mapping, would you be able to make the others? Would you be able to say, hey, wait a minute, 1 goes to 2, so one of the points is 1, 2. It also, 1 goes to 4, so 1, 4 is an answer. -2 goes to 4, 0 goes to 3. I have to be able to go through, given 1, find all the others. And that's all we're going to do.